All right, here are solutions for perfect problem 4 for Math 251. We're dealing with some trig derivatives here, so you're asked to prove that the derivative of cotangent is negative cosecant squared, and all you know is that the derivative of sine is cosine and the derivative of cosine is negative sine. However, thankfully for you, you have this quotient rule to use. So you like quotient rule, that usually happens when you got something that looks kind of like a fraction. I don't see any fractions here. True, but cotangent you might remember is 1 over tangent, and you might remember tangent is sine over cosine, and so therefore cotangent is cosine over sine. Okay, now I see the fraction, so I can use the quotient rule. I'm using the quotient rule. I don't know if we're using the f's and the g's still, but I'll go ahead and do that. I call the fraction on, or the function on the top f, the function on the bottom g, and if I could just figure out f prime and g prime, I'd be more or less done. I just have to put all these pieces together using the quotient rule. So I don't know, I kind of like doing this off in a box, at least when I'm first learning this stuff. So the derivative of cosine, oh right, that's given to me, that's negative sine. What about the derivative of sine? Well, again, that's given to me, that's cosine. So I can figure out the derivative of cosine over sine using the quotient rule. The quotient rule tells me the derivative of f divided by g is f prime, negative sine of x, times g, sine of x, plus g prime, sine of x, cosine of x, times f. Wait a minute, what happened here? F prime times g plus g prime times f. Oh, minus, that's why, because I'm using the quotient rule. So there's a minus going on here, minus g prime times f. All divided by g squared. But then you stare up at the top here and you're like, wait a minute, sine of x times sine of x, isn't that sine squared x? Yup. And what about cosine times cosine? That's cosine squared x, right? Yeah. So I got negative sine squared minus cosine squared. I could factor out a negative 1 and call that sine squared plus cosine squared. Why would you ever want to do that? Well, because we have this Pythagorean identity that tells you sine squared x plus cosine squared x just equals 1. So this is negative 1 over sine of x squared. 1 over sine is cosecant, so this is negative cosecant squared, which is exactly what I was supposed to prove that it was equal to. So I don't know, something like that kind of derives this formula. And you do something similar for cosecant. You're trying to figure out the derivative of cosecant. And the trick to that one, I guess, if you want to call it a trick, is remembering that cosecant is 1 over sine. So I don't know the chain rule at this point, so I'm forced to use the quotient rule. Playing the role of f, I don't know, maybe up here. F is equal to 1, g is equal to sine of x, f prime is equal to 0, because 1's a constant, the derivative of any constant is 0, and g prime, given to me in the problem, cosine of x. So I'll take all this information and throw it in the quotient rule down here to get that this is equal to f prime 0 times g sine of x minus g prime cosine of x times f, which is 1, divided by g sine of x squared. But wait a minute, 0 times sine, that's just 0. Cosine times 1, that's just cosine. So really all I have here is negative cosine of x over sine of x squared. Instead of sine of x squared, I'm going to write it as sine of x times sine of x. Why would you do such a thing? Well, cosine over sine, we saw that before, I believe. Yeah, here it is. Cosine over sine is just cotangent. So what I have here is cotangent. So really I have negative 1 over sine of x times cosine of x over sine of x. And negative 1 over sine of x, well, 1 over sine of x is cosecant. So I got negative cosecant of x times cosine over sine, as I said before, was cotangent. So I get exactly the derivatives I was hoping for here. Okay, and then in part 2 it says apply that knowledge. Use your answers to find the first two derivatives of cosecant squared. So figure out the derivative of cosecant squared. Well, again, we don't have the chain rule at this point. So all I can do is think about this as cosecant times cosecant, then use the product rule. Using the product rule, f is equal to cosecant of x, as is g. And as we figured out up here, the derivative of cosecant is negative cosecant times cotangent. And so g prime would be the same. So if I take all that information and I jam it into the product rule over here, I get that the derivative of cosecant squared is f prime negative cosecant x cotangent x times g cosecant x plus g prime plus a negative, I'll just write minus cosecant x cotangent x times f cosecant x. Wait a minute, what's going on here? I have cosecant times cotangent times cosecant. Isn't that just cosecant squared times cotangent? Yeah, it sure is. And I got two of those things, and they're both negative. So I have negative 2 cosecant squared x cotangent x. Something like this. And this is the first derivative. Unfortunately, I'm not done here because I'm supposed to find the first two derivatives. So this might be the first derivative. Let's figure out the second derivative. Maybe I'll label this a little better. This is my first derivative. Might be missing an R in there, but whatever. It's not an English class. I want to take the derivative of that thing to figure out the second derivative. So the derivative of negative 2 cosecant squared x cotangent x. Well, the first thing I can do is I can say that negative 2, that's just a constant. Let's pull that out in front and figure out the derivative of cosecant squared x times cotangent of x. Something times something, let's use the product rule. Okay, so I got the product rule over here. Playing the role of f is cosecant squared x, and playing the role of g is cotangent x. And the nice thing about g is g prime is immediate, because it's up here. We figured out that the derivative of cotangent is negative cosecant squared. But what about the derivative of cosecant squared? You might think that you have to use the product rule there. And I understand your logic for wanting to use the product rule there. It's cosecant times cosecant. But notice, that's exactly what we did up here. We already showed that the derivative of cosecant is this. So I get that g prime is negative 2 cosecant squared x cotangent x. And maybe I'll even say from first derivative. So now I have all the information that I need. Apply the product rule. Product rule tells me that the derivative of f times g is f prime. Oh, that should say f prime here. Man, now that just gets ugly. Okay, negative cosecant squared x goes over here. F prime, as we figured out above, was negative 2 cosecant squared x cotangent x, and this was from above. And now I can move on to applying the product rule. The product rule tells me the derivative of f times g is f prime, negative 2 cosecant squared x cotangent x times g cotangent x minus g prime. G prime's negative, so when I'm subtracting a negative, it becomes... No, I'm adding here. Sorry, I'm using the product rule, not the quotient rule. So plus negative cosecant squared. So I'll just write that as minus cosecant squared times f cosecant squared x. So I got f prime times g minus plus g prime times f. And I could call that good, or I could clean this thing up a little bit. I got negative 2 cosecant squared x cotangent squared x minus cosecant to the fourth x. Or if you feel like factoring, you can pull out a cosecant squared x from both of those guys, or even a negative cosecant squared x, and you'd be left with 2 cotangent squared x plus cosecant squared x. Are there any trig identities you can do with that? Well, let's see. Cotangent is cosine over sine. So I got cosine squared x. I'm just looking inside the parentheses here to see if I can do any simplification. Cosine squared x over sine squared x plus cosecant is 1 over sine squared x. So I could make it 1 plus cosine squared up on the top. But I don't think that helps me any because there's no Pythagorean identity won't help to simplify that thing. So I'm going to go ahead and leave it like this and call these two my final answers, whichever of these kind of you prefer, I guess. So maybe the box goes around the whole thing. And there's different forms that would be equally correct, but here's two that you'd probably come up with if you solve this problem using methods similar to what I did here. All right, I'll call that good.